Hello students, today in this basic fundamentals of inorganic chemistry part 3 we are going to take up the topics related to ionic and covalent character based on electronegativity, FAJAN'S rule, inert pair fact, oxidation state, oxides of an element. Very important the points fundamentally we are going to discuss. So let us start our session with a very good thought. A day of worry is more exhausting than a day of work. Means if we continue to do worry, the problems which are not in our control, we are living with only tension and stress, and will not be able to complete your work also. So start completing your task in hand and then think about others later. Okay, so learning outcomes, you will be able to explain about electronegativity effect on ionic and covalent character, dipole moment, FAJAN'S rule, inert pair fact, oxidation states, oxides of metal, non-metal, diagonal relationship, anomalous property of second period elements in the respective groups. So let us start. You know the basic periodic table and blocks also you are aware of as block P, D, F. We should know about the electronic configuration. We know that last electron is going to S orbital in case of S block, and in case of P block last electron is filled in P orbital, and in D orbital and F block in F orbital electrons are filled. What about the electronic configuration? So before that, if we recap what we have done in the previous videos, like atomic radius decreases down the group, and if I will just see that ionization energy, you know that atomic size and ionization energy is opposite. Atomic size in a period decreases, ionization energy, electron affinity and electronegativity as well, that are increasing in a period. Okay, and in the down the group, atomic radius is increasing, ionization energy will decrease, electron affinity will decrease, electronegativity will decrease. Next come to the metallic character. Down the group metallic character increases, along the period metallic character decreases, and non-metallic would be opposite to that of metallic. Okay, so let us come back to the general electronic configurations. General electronic configuration of S block elements is NS power 1 to 2. Similarly P, NS2 and P1 to 6. So it means to say that for 13 group NS2 and P1, and for 15 it is NS2 and P3, and for 18 it is NS2 and P6. So this is general about P block. Next is D block elements. So N-1, D 1 to 10, NS 1 to 2 means D can have 1 to 10 electron and NS can have 1 to 2, and NS and N-1D, that is N-1D is penultimate shell. Okay, the electron is added to penultimate shell, means one less than the outermost. F block is N-2 F1 to 14, N-1 D 0 to 1. Here students are making mistakes. They are writing here 1 to 10. That is wrong. So 0 to 1 only will be there in F block, N-2 F1 to 14, N-1 D 0 to 1, NS2. Please be careful for that. Now let us come back to the electronegativity, the table we have seen in the previous video also, just to see that which is the most electronegative element in the periodic table. If we see the values on Pauling units or Pauling scale, we can find that fluorine is having the maximum electronegativity and cesium is having the minimum electronegativity. It means cesium is most electropositive and fluorine is most electronegative. This is the point to here we can conclude from this table of electronegativity. Now next comes to the dipole moment. What do you mean by dipole moment? It is the product of charge, equal and opposite charge separated by distance r. Means if we take center of the atom, the distance between the two atoms of the center, and multiply by the charge on the one, means equal and opposite charge, plus q minus q. So q into r. It can be sometimes written as q into 2d, q into 2l, that way also can be written, depending upon what representation you have given for the internuclear distance between the two nucleus. Next, if HCl is there, the dipole will be there, or polar is there, dipolar. Dipoles means two poles will be there, positive and negative charge. Okay, so next is related to sum of the dipole moment of polyatomic molecules. For example, BCl3. Now in BCl3, chlorine you know that is having more electronegativity and boron is having less electronegativity. So the boron-chlorine bond, the electronegative direction is B to Cl in all the three cases. So now in this case, the two BCl2 bonds, that resultant of that will be just equal to the resultant equal to the BCl bond, means these two bonds resultant would oppose the third one. So net dipole moment would be 0. So similarly, if H and Cl we are considering, there chlorine is more electronegative, the direction of the arrow from H to Cl would be there. Similarly, if we are talking of formaldehyde HCHO, there also same hydrogen and carbon. Carbon is more electronegative than hydrogen, so therefore direction is from hydrogen to carbon. And if you compare carbon and oxygen, oxygen is more electronegative, so carbon, oxygen. So in this way, some dipole moment we can understand the dipole moments. Basic thing you need to take care is the molecule is symmetrical or non-symmetrical. If a molecule is symmetrical, that dipole moment will resultant dipole moment will be 0. All the individual dipole moment will be there. For example, let us take the case of CCl4 here. Carbon chlorine dipole moment is there. 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 But what is the point? Here is these three resultant of these three will be equal to the resultant which is opposite. So net resultant dipole moment will be 0. In the same case, CHCl3 is not like this. Why? Because you know that if you talk of hydrogen and carbon, hydrogen is less electronegative than carbon. So this also in the same direction. So it is not having any net dipole moment would be there, not 0. Non-zero would be there. Okay. Now ionic character. So electronegativity we have discussed, dipole moment we have discussed. More is the dipole moment, more is the ionic character. This is the basic thing. But let us see further. If difference in the electronegativity is 0, it means bond is purely covalent, and if the difference is intermediate, it's not more means it's not greater than 1.8, then it is intermediate. Intermediate means polar covalent bond, like water. If you are talking of large electronegativity difference, the bond would be ionic. Okay, so basic this table also given. If electronegativity difference is less than 0.4, then it would be polar covalent. And if it is between 0.5 and 1.8 is polar covalent, and then greater than 1.8 is ionic character. So now what is the basic conclusion we have to make? If the difference of the electronegativity is 0, then it is not polar bond. If the electronegativity difference between the combining atom is greater than 0, the bond is polar. And if the difference in the electronegativity of the combining atom is greater than 1.8, then the bond will be more than 50% ionic, okay, or less than 50% covalent. So this way we can find out the ionic character of a compound by using the difference in the electronegativity. Okay. Now if you take the sodium chloride case, the electronegativity difference is greater than 2. So greater than 2 means that will come under ionic character only. Now let us see the important topic, that is FAJAN rule. FAJAN rules is you should know that in ionic bond there are two types of ions, ion, cation and anion. Now you know the cation is normally smaller than the neutral atom, and moreover cation is smaller than the anion if you are talking of ionic bond. Now in case of cation, the electron cloud is more firmly attached. Why attached? Because already one electron is lost. Already there is a deficiency of electron, and that cation is not likely to give any electron. That can take electron but not give. So electron cloud in a cation is firmly fixed, but electron cloud in an anion is loosely held. So in that case, the cation tries to gain electron from an ion, or little bit shift would be there. That word is used as distortion. An ion to get distort, and capacity of the cation to distort means cation is distorting and an ion is getting distort. So this capacity is called polarizing power. Okay, because one is losing electron, another is gaining electron, or very small shift is there, or little bit only the electron cloud is shifted, not actual transfer of electrons. As the ion shifts slightly in its electrons towards cation, the positive charge of a cation decreases. So if positive charge is decreased, it means negative charge also will decrease, because magnitude we have to say and dipole moment also will decrease. So the point here to understand is that if the charge is decreased, the dipole moment will decrease or the bond will become covalent. It means when we are thinking of polarization, polarization is doing what? It is decreasing the character, ionic character of a bond. It is shifting the ionic character of a bond to covalent in nature. Okay, so that also polar covalent. So this is, you will understand more with this diagram. Cation and anion, you know that cation is smaller size as compared to anion, and cation is having positive charge and anion is having negative charge, and then there is distortion of electron cloud. Okay, when cation and anion approach each other. So on what factor this depend? Polarizing power depend on cationic charge, charge on cation divided by cationic radius. If smaller is the cation, if cation is smaller, polarizing power would be more. It will be easily, we can go for the polarization in that regard. Smaller is the size of cation, more is the charge of density, more is the charge density, more is the polarizability. This point we should keep in mind always. Very, very important point. Now, if low positive charge, we have discussed already, high positive charge, more polarization. Okay, small cation, more polarization. So this point always we should keep in mind. Okay, smaller cation, larger anion, greater the covalent character. This is also we can remember, this is a rule, very, very important rule. Okay, so you know that ionic compounds are having more melting point, but covalent compounds are having low melting point. So melting point would be, in this case, would be low. Now diagonal relationship. Period 2, period 3, main group elements. Diagonal group elements means lithium and magnesium are having similar property, beryllium and aluminium having similar property, carbon and phosphorus having similar property. Now, so why it is so? It is due to diagonal relationship. Now the question rises, why lithium chloride is covalent while NaCl is ionic in nature? So lithium chloride is covalent because cation size is smaller, and cation size is smaller. I have already told you earlier that as per FAJAN'S rule, smaller is the cation, more is the polarizing power, more is the covalent character. This is the right we have to write. Similarly, carbon tetrachloride is non-polar, whereas CCl3 is polar. So this again as per the dipole moment. So you can read this. I have already explained previously in the previous slides. Now boron, why boron shows similarity property as that of silicon? Second is, what is the dipole moment of carbon dioxide? You can pause the video and try, think, and then finally check the answer. That is the best way. So because of similar atomic size, diagonal relationship shows similar properties because what? Atomic size is same or polarizing power is same. This is the reason. Dipole moment of carbon dioxide will be 0. If you see the diagram which we have shown earlier also, the dipole is towards oxygen. Oxygen means opposite side of the center carbon is there, opposite side both have to go, then 180 degrees is the angle between the two bonds, and then resultant dipole would be 0. Now pair fact, very important fact, the phenomena of electrons remaining paired in valence shell means valence shell, these electrons will not participate in bond formation. The reluctance of Ns2 electrons of the valence shell to take part in bonding is called inert pair fact. Inert pair fact, it increases down the group. Why? Because there is imperfect shielding of d and f orbitals. If imperfect shielding is there, the more chance is there that Ns2 electrons will not go out for forming a bond. So this is the point. When you go down the group, what you are observing? Both oxidation states are there. If you talk of silicon, germanium, tin, lead, so tin is having +2 and +4. So now, if you talk of carbon family Ns2, Np2. So in that case, 2 electron can go from Np2 and 2 electron can go from Ns2. So therefore both oxidation states are possible, but as you go down the group in a periodic table, as you go down in a group in the periodic table, +2 oxidation state will be more stable than +4 due to inert effect. This question type of question can be asked in your exams. So these are the oxidation states of all the elements: alkali metal +1, alkyne earth metal +2, and D block will be having variable oxidation state, like now it is group 13 +3, 14, 15, 16, 17, 18. These are the group elements and the oxidation states. So you can see negative oxidation state is there for non-metal and positive oxidation state is there for metal. Okay, and that D block we are having different variable oxidation states. Now oxidation state in group 15. So it can show -3, +3 and +5. Okay, so now stability of +5 oxidation state decreases and that of +3 increases due to inert effect. I have already discussed that. So now here tendency to exhibit -3 oxidation state decreases down the group. Why? Because now as we go down the group, atomic size increases, ionization energy decreases, so electron will lose easily. So we are not going to gain electron now. Electron is a tendency to lose electron will be more for down the group when we are moving down the group. So this is the general electronic configuration you might have seen for 13 Ns2 Np1 and 15 Ns2 Np3, 17 Ns2 Np5 and 18 Ns2 Np6. So this way, highest oxidation state +3, because 2 electron can be lost from Ns2, 1 electron can be from Np. Similarly 2 + 2 4, and here 2 + 3 5. Here Ns2 Np4 6, Ns2 Np5 7, Ns2 Np6 8. So this way. So stability of oxidation state also depends on the solution, which type of solution is there. Hydration factor is coming into play, and how you are measuring is by measurement of ENOT values. ENOT what? Reduction values, as you have done in electrochemistry. So that ENOT value, more negative is the ENOT value, more stable will be that ion in the aqueous solution. Now let us try that how to do these questions. In group 13 elements, we have to check that which is more stable, +3 or +1, which is more stable? +1 is more stable. Answer by inert factor. So inert factor does not allow the 2 electrons to participate in the bond formation. Therefore, +1 oxidation state is more stable than +3 as compared to group 13 elements. Now let us talk about oxides. Metal oxides are basic, non-metal oxides are acidic, and intermediately amphoteric oxides also will be there. Let us see. So this is the B2O3, Al2O3, Ga2O3, and indium oxides strongly basic. So this is the acidic and basic character. Non-metal oxides are acidic, metal oxides are basic in nature. N2O5, P4O10, AS4O10, Sp4O10, Bi2O3. So these are the oxides of group 15, previous 13. Now the question is, which is more acidic, HClO4 or HClO? So what we have to do is we have to find the oxidation number. So you can calculate the oxidation number. You will find that chlorine is having 7 oxidation number for HClO4 and 1 would go for HClO. And name the metal whose oxide, hydroxide is amphoteric nature. Just see the answers. Okay, zinc, aluminium, lead are amphoteric oxides and hydroxides. Next is strengths of metal and non-metal. You see that left to right, non-metallic character increases, so covalent character will increase. Covalent character increase, then it's that we say that oxides, non-metal oxides are acidic in nature. So left to right, acidic nature would be there for oxides. This is anomalous pair. Anomalous behavior, like for example, you say nitrogen is not matching with phosphorus in regard to properties, oxygen not matching with sulfur, fluorine is not matching with chlorine, neon is not matching with argon. So this way, the question can be asked. So general electronic configuration should be clear. From the general electronic configuration also it is clear that In case of neon, we don't have 2s to 2p only. So we don't have 3d orbitals also. So means to say that in this nitrogen, oxygen, fluorine we don't have d orbitals. So in detail you can just see nitrogen is having small atomic size as compared to two other atoms in a group, 15. Highest electronegativity of nitrogen in comparison to other elements in group 15 means nitrogen is the most electronegative. Third is highest ionization energy in a group 15. In a group 15, ionization energy is maximum in case of group 15. Absence of d orbitals, because nitrogen does not have d orbitals, because if you talk of n is equal to 2, L can have value from 0 to 1, so S and P only are possible. And absence of d orbital, nitrogen is gas while others are members are solid. So because why solid? Because they exist as associated molecule like P4, S8, so this one. Nitrogen being highest electronegativity, why electronegativity decreases down the group. So this trend we have already understood, just as a reminder call. Nitrogen form p-pi multiple bonds, whereas nitrogen forms p-pi multiple bonds, whereas other element shows p-pi multiple bonds, because the d orbitals only basic thing is d orbitals. Multiple bonds means double bond, triple bond. Nitrogen shows -3 to +5 oxidation state, whereas the element shows limited number of oxidation states. Hydrides of nitrogens are basic, only for ammonia is more basic, while others are less basic, and down the group basicity of hydrides decreases. And let us try two questions more. Why fluorine is having less electronegativity than chlorine, and why fluorine cannot have positive oxidation state, whereas chlorine can have positive oxidation state. So the answer for these questions are, because fluorine is having less electronegativity because of more repulsions between what valence electron and the new incoming electron, because of small size. Similarly, fluorine cannot have positive oxidation state, whereas chlorine can have, because fluorine is the most electronegative element in the periodic table. So therefore, any other atom combining with fluorine would be having positive oxidation state. So congratulations to you if you are able to give the answers correctly, or few questions you might be not clear, no problem. But the thing is that if you are doing practice regularly, then you will get the desired. Euphoric is more exhausting than a day of work. Thank you.